Hello, my name is Samyak Gosalia, a third year undergraduate BTech student at IIT Gandhinagar from the discipline of electrical engineering. So today I am going to explain about our project 2 of digital signal processing course. Let me just quickly briefly explain like what we have done in this project. So in this project we have developed an finite impulse response filter design application using MATLAB App Designer, which is aimed to providing an intuitive interface for designing and visualizing different types of filters. So the application allows users to create customized filters based on their specification and visualize the results in real time. So the main features of our application includes the first filter type selection, from which we can select or user can select from variety of filters such as low pass, high pass, band stop using a drop down menu. Then second, passband and stop band frequency configuration. So the application allows users to input or select frequency ranges for the passband and stop band using a slider. The user can also specify the desired order of the filter. Then third, we have generate filter button. After selecting the filter type and configuring the parameters, users can click the generate filter button to initiate the design process. Then fourth, we also have real-time visualization. Upon pressing the generate filter button, the application generates a filter and displays several important design metrics such as generation numbers, which indicates the current iteration of the filter design process. Then second, pole zero diagram, which visualize the location of pole and zero in Z domain for current filter design which user have selected. And third, frequency response, which displays the filters frequency response, showing how filter attenuates or passes different frequency. Additionally, application also employs genetic algorithm optimization to iteratively refine the frequency response and pole zero diagrams until a well designed filter is obtained, ensuring the filter meets the specific requirements. So now let us have a look how we have implemented this using MATLAB.
Hello, my name is Dipesh Padidar. My roll number is 22110077. So here is the final app of our project 2. So let us look how it is looking. So here we see the pole zero diagram. Here we see the frequency response, and here is to set pass band frequency and band pass frequency. From here we can set the order of our uh, filter, and here we can select all our low pass filter, high pass filter, bass pass filter, and the other filters. Here is the generate button. So now let us look on the code, how the code is looking. So here is our code. So from the generate, when we click the generate button, it's take data from the filter, from the pass band, from the stop band, and from the filter button. All the data were taken when stored in these variables. After that, if our pass band frequency is higher than the stop band frequency, then it sends the alert. Since the stop band frequency should be higher than the pass band frequency. After that, using the genetic algorithm, we are going to generate the optimal coefficient. For that. Then after we generate the optimal coefficient, then we divide it into the magnitude and frequency using the Fritzsche function. The frequency range is from 1 to 1025. After that, we have to plot the frequency versus magnitude plot. So here we plot the frequency versus magnitude plot, and the magnitude of is in dB. And then we label the x label, which is our normalized frequency, and the y label is magnitude in dB, and the title of the is frequency response. After that, we have to plot pole zero diagram. For that, we store the value of zeros where where the optimal coefficient is 0. So it is a root of optimal coefficient, and the pole should be placed at 0. So after that, we in the first diagram we plot the pole zero diagram. So real z, imaginary z, we mark with 0. This is for 0 and this is for pole. Then we label the x label and y label, and the title of the plot is pole zero diagram.
So this is the final MATLAB app of our project 2. So in the app we have a pole zero diagram, a frequency response window, and a filter type where we can select the filter which we want, like low pass, high pass, band pass, and band stop. And we have label pass band frequency and stop band frequency label. We have to carefully look at that label pass band frequency should be always less than stop band frequency label. And we have a filter order where we can select what order of filter we want. So let's say I am selecting 15, so we are performing for filter order of 15. So I am clicking on generate button. So this is the pole zero diagram. This is the pole zero diagram for order 15, and this is low pass filter. So we can see that all the low frequencies are passed and high frequencies are blocked by 0. And this is the frequency response. As we can see that low frequency is passed and high frequencies are stopped. So now I'm performing high pass filter. So I am selecting, let's say, label band frequency at 0.4 and stop band frequency label at 0.6 and filter order at 16, and I am now clicking on generate button. So this is the pole zero diagram of high pass filter. We can see that all the frequencies which are higher are passed, and all the frequencies which are lower are stopped by placing 0 at that points. And this is the frequency response graph. We can see that high frequency are passed and low frequencies are blocked by zeros. Now band pass. So now I am selecting a label pass band frequency at 0.3 and stop band frequency label at 0.6 and filter order at let's say 17, and I'm clicking on generate button. So this is the band pass filter. At the pole zero diagram we can look at that the band pass filter is performed, and frequency response graph we can see that a band is a frequency from 0.3 to 2.8 is passed and all others are blocked. Now I'm performing band stop and selecting stop band frequency level at 0.5 and filter order spinner level at 18. So this is the pole zero diagram of band stop filter, and this is the frequency response of band stop filter. So we can see that the frequencies which are in the range of 0.5 and 2 are stopped, are lowered or stopped. They became very low. So this is the band stop filter.